Welcome back, students. So here we are on the third phase of our journey, and in this we are going to study about important terms in the binomial theorem. Okay, till now we have discussed, okay, how does a binomial look, what is a theorem, and what were some important points regarding to expansion. Here we are looking at the key terms which are used in binomial. For example, middle term. If I am expanding an expansion, okay, so what will be my middle term? A term independent of x, and we will be also studying about the general term. Okay, so these three will be forming the basics of what we are going to do in the coming parts, and these will be frequently used. Okay, the concept related to these three terms will quite frequently used in the coming videos. So let's begin with this part. Okay, let's see some important terms in binomial. As I mentioned, we will be studying a general term, term independent of x, and middle term in this part. So let's look at each of them one by one, and we'll see that how these are again going to be very useful as we are going to do some IIT-JEE concepts later on. Now, till now, whatever we have done is a foundation, okay, and again very basic things. After this part, the things are gonna be tough. Okay, so if you are very clear with this, we can easily play with those terms. But if you are not, then again it's time to revise again and do these things. Okay, so let us talk about them one by one. So general term, as I was saying, I start from here, x plus y raised to power n. So as the expansion was going like this, n c0 x raised to power 100 plus nc1 x raised to power 99 y. So what were we doing basically? Okay, now general term means that I can just put the position of term, and suppose this is the first term. So what should I do so that I put 1 in that term and I get this? Okay, so obviously I have mentioned that we relate, since this is 0, we need to basically 100 is something dependent on n and 0. In this case, suppose I have taken x as this as 100, or if I write it in general, okay, I'll use some different color. Okay, if I write it as n here, this will be n minus 1 here. So basically what is the thing which is actually deciding the powers and everything? This is the term, and n is being constant every time. This one in the next term, this will be nc2 x raised to power 100 minus 2 y2. So obviously you are seeing that this 2 is actually playing the role. Okay, so how we are gonna write this in terms of position? Okay, so this is first term, this is second term, this is third term. So I need to put 2 to get 3. So basically I am looking at T3 in terms of 2. So I need basically 1 plus 2. Okay, for this I need T2, that is T1 plus 1. This one is here. So in general I can write TR plus 1, and rest everything remains the same. This is 100 minus 2, or 100 minus r we can write general. If I write here TR plus 1 as NCR, this is clear now. And again we can write the power of first thing as x raised to power n minus r. Okay, 100 was used as n, so n minus r, and y raised to power next term is, for this it was 2 only, for 1 it was 1 only, so it will be r only. Again, the powers of the second term, they are beginning like 0, 1, and so this is very easy to understand. Okay, now I hope this thing makes very clear, because we are going to use this again and again in all the concepts which we'll be studying after this. Okay, so make yourself very clear with this. If you need, you can pause the video right now here and again look at this again, write your choice. Okay, so after this let us look at the middle term. Okay, so middle term, again, as the name suggests, the central term. Okay, so obviously if I'm having index n, I'm having n plus 1 terms. Okay, now in this the middle term will depend on n plus 1. Okay, so if n plus 1 is odd, obviously there will be one middle term. For example, if I'm having three numbers, clearly the middle one is a, so basically in that case n plus 1, so in this case it was 3, so 3 plus 1 by 2 will be the middle term, so n plus 1 by 1 will be the middle term. Or we can say, conclude that if n plus 1 is odd, n is even. So in case of n is even, then you will say that n by 2 plus 1 is the middle term. Okay, for example, if I am saying n is equal to 5, it means r is equal to 3, or t3 basically is the middle term, not r equal to 3. So for that we need to put r as 2. Again I'm going to expand this again in this. Okay, I took n as odd, n should have been even. So if n is even, basically 4, this one we will take after this, n is equal to 4. So in this n by 2, that is 4 by 2 plus 1 is gonna be the third term. Okay, so let me write it here, that if I'm taking, suppose, x plus y raised to power 4, so it will be x4 first term, coefficient let it be a0, a1, x3 y plus a2, x2 y2 plus a3 a3 x1 y3 plus a4 x4 y4. So in this, clearly as you can see, r equal to 2 is the middle term. Okay, so third term will be the middle term, and corresponding to t3, r will be equal to 2. Okay, now what happens when, I'll continue from here. Okay, what happens if your n is odd? If n is odd, n plus 1 will be even. So in that one, suppose if I am taking n is equal to, suppose, 3. Okay, so we will have 4 terms. So out of those 4 terms, obviously 2 terms will be the middle terms. Okay, so there will be having 2 middle terms for that. And again, for this, again you can correlate it with the position, n plus 1 by 2, n plus 1 by 2 plus 1, that will be the 2 middle terms. Okay, so you just need to, and this is again the position of the term, this is not r. Okay, keep in mind, second and third term from this you will get, okay, as the middle terms, and 2 and 3 will be the position of terms. R for this will be equal to 1, R for this will be equal to 2, as you can look from here. If you are going to T3, it will be basically R equal to 2, because everything else in the formula depends on R, not on this 3. Okay, so keep that in mind. Okay, term independent of x. Again, this will be using the same, we will be using the same concepts of general term here, and that we will basically using the same thing. Okay, now here again you note that in this term independent of x means we are talking about an expansion. Suppose even if I take this expansion, okay, I need, in this obviously you will say, okay, it's obvious that the last term will be the term having term independent of x. But in general, what will happen if I write a general term now? Now this y, if it's a function of x, suppose if it's given in the question like expansion maybe of this x square 1 by x cube, maybe like this. Okay, and suppose you have to find the term independent of x in this question. Okay, so for this, what will be the general term? Tr plus 1 will be equal to, now again n is specified here, 5 cr x raised to power 2 raised to power 5 minus r and 1 by x cube raised to power r. So in this question you have to basically equate the powers of x from here and from here as 0. So from first, the power of x will be 2 into 5 minus r. From second, it will be plus minus 3r. Why? Because it will go up, so minus 3r. Now this is the power of x. Term independent of x means you have to find that value of r for which the overall powers of x will get cancelled out. Okay, so that is again, if there is x in one term only, then you will always find that the last term will be term independent of x. Now suppose if it would have been in numerator, then there will be no term which is independent of x. Only when there will be either one term in numerator, denominator, or we will see more examples definitely for this when we will be solving the questions. So right now the term independent of x means you have to equate the powers of x as 0, and that powers you will get from the general term. Okay, so general term again is very necessary in this. In this middle term also it was again very necessary. Okay, so let's look at some questions now. Now the term independent of x in the expansion of this. Okay, again a good question. Yeah, so it says the term independent of x in the expansion 1 plus x raised to power n. Okay, now again we can just multiply this since the powers are same, and then we can expand. Obviously other way would be quite lengthy. If I expand this, in that again I have to cancel out the factors, so that will be again waste of time. So first we'll combine this thing again. When we will solve this, what we will get, 1 into 1 will be 1 plus 1 by x plus x plus 1. Okay, so this will be again raised to power n, and from here I can write it as, again you can see that it will be 1 plus x if I solve this, plus x square plus x if I take the LCM. Okay, this will also be x again, divide by x raised to power n. Okay, yes, so this will be 1 was here, sorry, so x plus 1 whole square in the numerator divided by x raised to power n. Now as you can see, the question becomes quite easy now. Now what we have to do, basically x plus 1 raised to power 2n upon x raised to power n. Now keep in mind that the term independent of x, obviously this x 1 by x raised to power n will be outside of whatever the expansion. So for finding the term independent of x, we need to find term which is having x raised to power n. Okay, so first let us write it like this, 1 plus x, because so that we can correlate it with the general formula. So we need to find the coefficient of power such that the power of x is equal to n. Okay, so we need to go for the coefficient which is having this one. Okay, so obviously as I mentioned, tr plus 1 will be ncr. Now in this first one is 1, we don't need to worry about that, so x raised to power r. Now in this case n is basically 2n, and the power which we required is n, so this will be n here, n plus 1 n. Now this term divided by x raised to power n obviously will give me the coefficient or the term which is independent of x, which is indeed only 2n cn. This is the term which is independent of x, and again in terms of number it will be tn plus 1. That will be the term which is independent of x. So how do we again get that? So we put here x raised to power r, we needed x raised to power n, so we put it r as n, and from that we got tn plus 1 as the term independent of x. Let's look at the next question. The positive value of a, so that the coefficients of x raised to power 5 and x raised to power 15 are equal in the expansion of this. Okay, so here we need to find the a. Okay, so x raised to power 5 and x raised to power 15, again good question. Okay, so we will write the general term for this. What will be that? tr plus 1, this will be equal to 10 cr x square raised to power 10 minus r into a upon x cube raised to power r. Okay, now we need to get x raised to power 5 and x raised to power 15. Now what is the difference between independent and if you are equating finding some coefficient, in that cases we were equating it to x raised to power 0. Yes, now we are finding it will equate it to x raised to power 5. So let us figure out what is the power of x. X will be equal to 2 into 10 minus r here, okay, and we have to again need that this is a positive value, okay. So from here what we will do, we will first find r, and from that r we have to see that the coefficient should be equal, okay. Coefficient will be depending on r value, because that will take a raised to power r, okay. Now this is the power of this, and x raised to power minus 3r, okay. Now here first you will find for what value of r this will be 5, okay, because we are now again please note here that when you're looking at x raised to power 5, when we are going for this expansion, maybe in this clearly it will be 10c5 x raised to power 5. By now you must be comfortable with this, but when there are functions involving inside, then you can't straightly put like that way. Then you have to go for general term. From general term extract out the powers and get the r value, okay. So that is the key logic that will be involved in this question, okay. So this will be x raised to power 20 minus 2r minus 3r, which will be x into 20 minus 5r. Now for 1 it will be 5, 20 minus 5r will be giving me 5, so you can clearly see r will be 3. For getting x raised to power 15, that is equal to 15, r will be equal to 1. Okay, now here we have got the values of r. Now what do we need to do? Now we'll equate the coefficients. Now we don't need x here. We just need 10c3 a raised to power 3. This will be equal to 10c1 and a raised to power 1. Now from this you can clearly get a square will be equal to 10c1 over 10c3, and you can accordingly get the answer, okay. So this is the crux. Again, what is the main logic? We cannot get x raised to power 5 simply, okay. Now again this is using the concept of binomial theorem. We could have, if you expand it like this way 10 times, it's very difficult to even think about x raised to power 5. But what does the binomial theorem says? Okay, let's assume it as one quantity as x, y. We know the general expansion, and from that what we are saying, it will have some powers of x, it will have some powers of x. Now both are being multiplied to some power, so we can solve their powers and equate it. That is the crux behind the logic. If you have any doubt in this topic, you can post it for free on Ask IITian website. For this, just visit the askIITian.com, and there you can visit discussion board. It will direct you to Ask Expert, where you can select the category, and according to the category post your question and click the Get Answer button. Experts at Ask IITian will answer your query within 24 to 48 hours. I hope you are clear with the three ideas, and the main thing I will again highlight is to pick up a certain power of x that we have learnt, okay. Like we were going for term independent of x. In that we were basically raising the power to be 0, okay. So instead of 0, if I am requiring x raised to power 7, 4, 3, anything. So the main thing which we have learnt here is to pick out the coefficients corresponding to particular powers of x. So I hope that I was successful in explaining this, and please perform a lot of questions based on this, so that the advanced thing which we will be doing in coming parts are easier to understand and grasp. Stay tuned for the next part.